Hello, everyone. I see Nadia is here. Levi, BK, Travis, Jessica. Thank you for being here, George and Levi as well. Hi, everyone. Welcome to today's free live lesson. If you could do me a huge favor and put a plus in chat if you can hear me, that would be awesome. Again, I see Nadia, Levi, Amy, welcome, Jessica, Travis. The double plus, love the enthusiasm. Welcome. 5 p.m. on a Wednesday, Pacific time. We love it. Just curious, when did everyone start school? Did you start 3 weeks ago, 2 weeks ago, a week ago, maybe this week? Maybe you haven't started yet? Anyone hasn't started school yet? When did y'all start the school year? I think my high school started about 2 weeks ago. Plus her family. Hi, Mookie. Welcome. 2 weeks ago. Started last week. 1 week ago. Great. Getting into the hang of things. Your schools probably might have not started much math yet, which is really exciting. You're getting to know everyone again. Maybe starting middle school, which is really, really exciting. Maybe getting near the end of middle school, starting 8th grade. Ready to culminate already at the end of the school year. All right. Well, thank you for all your responses. Thank you for being here. All right, let's get started. So you are in the right place if you signed up for a free live lesson for grades 6 through 8 math. Today we're going to be playing with fractions. If you meant to sign up for Algebra 1, that stream will actually be tomorrow, 5 to 6 p.m. Pacific time. So same time tomorrow. That'll be Algebra 1. And you can sign up for that via the link in the YouTube description. So you can click that link and you'll also see that there are lessons for geometry and Algebra 2 as well. Those will be going on starting next week. And before we start, or before we move any further, let me introduce myself a little bit. Hello, I am Eddie Kang. I grew up with immigrant parents. I only spoke Korean at home. So math as a universal language acted as a bridge between my life in school and at home. I did really well in school. I got A's in all my math classes, got a perfect score on the SAT, and eventually got accepted to my dream school, UCLA, where I majored in math. After graduating from UCLA with a degree in math, I started teaching right away, and I've taught every grade level from 6th grade all the way to college calculus at UCLA. I was also a private tutor for some time. And yeah, Travis, I want to go to UCLA. Yes, go Bruins. All that to say, my students have gotten into the top universities. They've exceeded the standard on state tests. They've gotten 5s on AP exams. For those of you in middle school here might not know what an AP exam but it's basically a college course you can take in high school to get college credit. And yeah, they just really excelled. But most importantly, they had fun along the way. And that's what we're here for today, playing with fractions. But before we start the fun, if you can do me a huge favor, copy the URL at the top of your browser and share it with just one friend or a family friend that you know that might want to enjoy the fun today. Just join the hype train and chat today before we get into it. All right, and with that, let's begin. I love starting my lessons with a vibe check just to get the gauge of the air, the atmosphere, what we're like, what the mood is. Let's start with this. In the chat, which one of these types of 4 chocolates is your favorite type of chocolate? So A, you got the little bars that you can break up. B, you have these M&M looking things. C, looks like a Kit Kat. And D, looks like maybe Snickers bar or Twix, anything like that. Travis says C. Amy says C. Wow, we got numbers 1, 2, 3 just in the chat. Kit Kat, awesome. Jessica says Kit Kat. Mookie says A. Yes, Hershey bars. Love them as well. Jessica says C. Great. Awesome. Thank you for your responses. My answer to this one would have been B, maybe 10 years ago. I used to love those mini M&Ms that are in the little plastic bottles. I don't know if they sell them anymore, but I used to love those. But now my favorite would be C as well. Kit Kats. Love Kit Kats. Hi, Jimmy. Welcome. Number one fan in the chat. Fan in the chat. Yes, Jessica. Congratulations. Let's see if you can keep it all the way through the entire stream. Travis, you too. You're quite close. Let's see who ends at number one in this stream today. All right. We also like to start with APKs. I call these APKs by the acronym for Accessing Prior Knowledge. So today we're going to start off by refreshing our memory, hopefully refreshing. If you've never heard this before, don't worry. I will get you started right here about mixed numbers and improper fractions. All right, if I could find my pen, there it is. An improper fraction is one where the numerator is greater than the denominator. For those of you that may have never heard what a numerator or denominator is, and your math teacher call it the top of the fraction and bottom of the fraction, where the numerator comes from a Latin word, numerus, meaning count a number. The denominator comes from a Latin word called nomen, which means the namer. So it names how many equal parts are in the whole, and the numerator counts how many actual equal parts there are that we have. So that's an improper fraction where the numerator is greater than the denominator. We call it improper because a fraction, when it was first discovered and used, we always had a smaller number on top of the bottom number because we're taking some part of a bigger whole. And eventually, improper fractions came about where now the numerator was a lot bigger than the denominator. An improper fraction can also be written as a mixed number. A mixed number is a whole number attached to the fraction where the numerator is now smaller than the denominator, like a fraction is supposed to be. A proper fraction, I guess you can say. So for these two examples right here in two different colors, two different shades of blue, we're going to write each situation as a mixed number and an improper fraction. And then we're going to see if there's a method for converting from one to the other. Let's take a look at the darker shaded blue here. We have one full circle, two full circles, and we can tell that each circle is split into 4 equal pieces. So if we were looking for an improper fraction to notate this visual, we have, 4 pieces. So our denominator would be 4. Nice. I see Jessica and Travis are ahead of the game here. We'll be over 4 total pieces in a whole. And now we count up each piece. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces. So this is the improper fraction that represents this visual. 13 over 4. Close. Make sure you're counting correctly. We have 4 pieces in each. That makes 8 plus that 3 out of 4 in that last circle. 11 out of 4 is our improper fraction. Now, let's think about the mixed number. There are 2 wholes here, so we know that there's going to be a 2, and this last circle only has 3 equal parts out of the 4. So we have 3/4. So what we just found here is that 11/4 is equal to the mixed number 2 3/4. So now how do we convert from one to the other? Great, Travis. 11 minus 8 is equal to 3. Now, what is Travis saying in the chat here? For those of you that not sure where 11 minus 8 came from, 4, let's think about how many times does 4 go into 11 fully? 4 times 1 is 4. 4 definitely goes into 11. 4 times 2 is 8. 8 definitely is less than 11. But as soon as we hit 4 times 3, that's now 12. 12 does not go into 11. It's now bigger than 11. So the number of times 4 goes into 11 fully is twice. So we go, okay, so 4 plus 4, and what's left? 3. And that's all over 4. And we know that 4 plus 4 over 4 will be 2, and that's where we get the 2 3/4 from. If we were to go the other way, 2 3/4 means there's 2 full 4s. So we go, okay, we'll have 2 times 4 plus that remaining 3 on top, all over 4. And that gives us, using order of operations, or we also know PEMDAS, 4 times 2 or 2 times 4 is 8, plus 3 is 11 over 4. And we'll do something really similar with this next one. We'll find the mixed number and we're going to convert it into an improper fraction. Nabil, welcome. I got that. Too nice. Amazing. Welcome, welcome. We have 3 full circles here, so we know that our mixed number will start with a 3. And then we recognize, we count 1, 2, 3, 4, 5, 6, 7, 8. There are 8 total equal pieces in each circle. And we have 1, 2, 3, 4, 5 equal parts out of the 8 in our last circle. So we have 5 eighths. Now let's try to convert this mixed number into an improper fraction. I see Amy, Travis ahead of the game. This is easy. Yes, this is just our APK, accessing prior knowledge. We should already know this, but if we don't, I just wanted to give you a quick reminder here. So we have 3 full 8s. We have 3 times 8 plus the 5 all over the 8. We have 24 plus 5 over 8, and that equals 29 over 8, just like that. And that is our improper fraction to represent this second visual. All right, 10 minutes in, and we've already now fully locked into the math. This is why I start with a vibe check and APK usually per lesson. I like to get our gears running before we instead of just going straight into some math. We're building confidence, right? Building confidence. Jimmy, why improper? Are you asking why are these fractions called improper fractions? Yes, this is to make us feel a little good, pat ourselves on the back before we get into the nitty-gritty. Yeah, it's called improper because when fractions were first discovered in history in general, let's say we had something and we wanted to cut it into 3 pieces. We said, all right, there are 3 pieces. How many of the 3 pieces do you want? And they said, oh, I just want 1 of those pieces. Or I just want 2 of those pieces. Or I just want the whole thing. Give me all 3 pieces. If you had something and you split it into thirds and you asked the person, give me 4 of those pieces, would that make sense? No, because there are only 3 available, right? So that's why once we discovered these fractions, we called them improper. And that's why we came up with another way to write them as mixed numbers as well. It's not that they're wrong. They're just called improper because when they were first discovered, we decided, okay, let's just call them improper for now, but then it stuck. 2/3 would be considered a proper fraction, but we don't really call them proper fractions as well. They're just called fractions because they're the OG fractions. Great question, Travis and Jimmy. Thank you for asking that. As always, I'll say this every lesson as well, there is no bad question. If you have a question, chances are that 5 others had that same question, but were too shy to ask. So if you're one of those that are too shy to ask, just ask the question. Don't worry about anything. We're all here to learn. We're all here to have fun. And it's only fun when we're all in it, right? So let's keep it going. Love the interaction here. Let's run it. All right, getting into today's playing with fractions. First, we're going to start with multiplying. Imagine you have a chocolate bar. Let's say this chocolate bar, like we talked about in the vibe check, is broken into 2 equal pieces, and you have 1 of those pieces. We can call this 1/2 of the chocolate bar because out of the 2 pieces, we have 1 of them, right? We just talked about improper fractions, mixed numbers. We talked about the numerator over the denominator. Now pretend you want to share your piece, your 1/2 of the full piece with your best friend. You decide to split that in half and give them 1 of those halves. So you're sharing half of your half. Whoa. Think about it like this. When you share half of your already halved chocolate, you are not giving all of it away, right? You're giving half of what you currently have. Just some of them. When we talk about multiplying fractions, we're talking about sharing a part of something. With our chocolate bar, you first took half. That's the first half. Then from your half, you shared half again. Lots of halves, right? That's the second half. This means you shared half of your half, or 1 out of 4 parts of the whole chocolate bar you started with. That's why we say half times half, or 1/2 times 1/2 is 1/4. And this pattern happens every time, right? We study fractions and we recognize and we discover, wait, this happens every single time. So can we generalize this into some rule that we can follow for more complex looking expressions? And that's where we get this. To multiply fractions, we simply multiply the numerators together and the denominators together, just like that. Chocolate fingers, you're hungry now? Dinner time soon, right after this lesson. Much deserved dinner coming soon. All right, so multiply the following fractions. Let's take a look. Part A, 3/7 times 5/8. We're going to multiply across the numerator and across the denominator. But I'm going to show you something that you may not have seen in school. Instead of just saying 3 times 5 is 15 and 7 times 8 is 56, great Nabil, we can rewrite this for future purposes. We can rewrite this all as one fraction, 3 times 5 over 7 times 8. And that will give us 15 over 56. Whether you got it this way or not, if you got to this answer, amazing. Let's try part B. We have 4/9 times 7 over 11. So we're going to first rewrite this as 4 times 7 over 9 times 11. This is a hack. Watch carefully. 4 times 7 is 28, and 9 times 11 is 99. And currently, with our two fractions that we just worked with, there aren't any common factors. There aren't any common factors between the number in the numerator and the number in the denominator. So we can't simplify. This is its fully simplified form. Now let's look at letter C. 2/5 times 3/8. This will equal all over one division bar. By the way, we call this a division bar. Over 5 times 8. 2 times 3 is 6, and 5 times 8 is 40. But now, check this out. 6 and 40 have a common factor of 2. How do we know? Because 6 and 40 are both even numbers. Even numbers are always divisible by 2. So if we divided or we canceled out those common factors, or the common factor of 2 from 6 and 40, 6 divided by 2 is 3, and 40 divided by 2 is 20. So our final answer here will be 3 over 20. What if we don't cancel? Now, if we don't cancel, 6 over 40 is still a correct answer, but oftentimes in school, you will be asked to write your answer in its fully simplified form. And fully simplified means there cannot be any common factors. You have to simplify them out, cancel them out until there's nothing else to do. So make sure that is the case. Great question. What does common factor mean? Great question, Amy. 6 over 40. 6 over 40, or let's take 6 and 40. 6 and 40. A common thing to do is a factor tree. So 6 is 2 times 3. 40, we can start with 2 times 20, then 2 times 10, going to 2 times 5. So our factorization of 6 shows us we have a factor of 2 and a factor of 3. For 40, we see a factor of 2, 4, 8, 10, 20. And a common factor here is 2. What's a factor tree again? Notice how this kind of has branches, so it looks like a tree. That's what we call a factor tree. A tree full of factors, branching out into more factors. So this is also known as prime factorization. Looks like a Christmas tree, yes. Is it 3 more months? 4 more months until Christmas? 4 months. 4 months minus 2 days until Christmas, everyone. All right, let's keep it moving. My teachers never explained it this nicely. Oh, Amy, thank you. That's what we're here for. I'm glad we're having fun and learning new things. All right, now, as we saw in the last part of the previous example, we could simplify the last fraction further. But we could have addressed this before we had even multiplied the numerator and denominators together. We know that 2 times 3 is the same as 3 times 2. And we can use this idea when multiplying fractions. If we want to name this, 2 times 3 is the same as 3 times 2. You may have learned this as the commutative property. Commutative property of multiplication. This means that whenever we multiply two terms, we can switch them back and forth and we'll get the same exact thing every time. Because multiplication is simply repeated addition, and addition is also commutative. Okay. So let's look at our previous example again. What we wrote down earlier was we said 2 times 3 and 5 times 8. We said, this is 6 over 40. We canceled out the common factor of 2. Oops, that's a mistake. This should be 3 because we're canceling out that common factor of 2. And we get 3 over 20. Now, I'm telling you, we could have done that simplifying earlier. Because if you look, 6 and 40, 40 tends to be a bigger number, right? It's a bigger number than any number we've seen with 2, 5, 3, and 8 in the original problem. So let's rewrite this as 2 times 3 over 5 times 8. Let's see if we can rewrite this as 3 times 2 over 5 times 8. And now check this out. 2 and 8 have a common factor of 2. 2 is divisible by 2, becomes 1. 8 is also divisible by 2, becomes 4. And now we multiply. 3 times 1 is 3, and 5 times 4 is 20. We got the same answer, but on our way there, we worked with smaller numbers. And generally speaking, when we work with smaller numbers, we decrease the probability of making a careless error. The bigger numbers get, the more likely an error happens or an error occurs. So we like to work with smaller numbers. This goes the same with when we're going to cover negative numbers. We like to get rid of the negative by multiplying by negative to work with positive numbers, because that decreases the probability of making a careless mistake. And especially in math, on tests, there is a lot of test anxiety, and that's because there are so many problems we have to solve in one test. So we try to minimize the probability that we make an error. Eddie already talking about Christmas. Yes, the holidays are a great time, isn't it? Especially in LA when it doesn't snow. It's just, very brisk, cool air. We just love it. Yes, great question, Travis. So 2/5 times 3/8 would be the same as 3/5 times 2/8 because, again, multiplication is commutative. Do I need to know this for school? Is it okay if I don't cancel? Don't cancel as in, like, simplify? We want to simplify. We always want to simplify when we can. That's the general rule. I'm not going to say not to cancel because it's safer to always cancel. Good question, Mabel. Oh, Mabel, welcome. I don't think I've said hi to you yet, but welcome. All right, let's practice. I'm going to give you about 2 minutes to try these on your own, or maybe a minute to get started on these, and then we'll talk about them together. Try it out. You can try it on your own. Please don't message it in the chat until I ask you to do so, if you'd like, just so everyone can get an opportunity to solve these problems. I'll give you about a minute. Bigger numbers, yes, bigger numbers. So use the method that we just talked about to help you out. If you're stuck on where to start, I encourage you to at least write these problems down and maybe try something, right? A lot of math is just about trying, right? Just starting the problem. It's 50%. Taking that first step is 50% of the work. So just try something, right? Don't wait for me to do it, because then I'm taking all the fun out of it. I'm just showing you how to do it. You're not going to know how to do it after I do it, right? So try something. I'll give you another 30 seconds here. Amy's done. Amazing. Oh yeah, if you're done, that's a great idea, Amy. If you're done, you can chat done. Maybe I'm waiting too long. Maybe you all are just ahead of the game and I'm just holding you back. Hopefully I'm not. All right, that was about 30 more seconds than the minute that I promised, so about a minute and 30 seconds. Let's try these out. I will try letter A here. Looks a little more intimidating because the numbers are bigger, but let's try it. 5/12 times 8/15. This is equal to, again, I'm going to put it over one division bar. This is just a habit I have. And for those of you that are thinking, well, you don't have to do that. You can use something called cross cancel. You can use this. You can use this, this, this. I use this habit because, like I said, I've taught every grade level until calculus. And when the expressions become more complex, it's the foundational habits that are going to hold you back if you don't have like solid foundation in this type of math. This may look really easy. This may be really easy right now. Maybe it's not, but eventually it will become easy. But foundational habits, really, really important to succeed later in your mathematical career. So again, we put it over one division bar. Very simple thing to do, but we're going to make it a habit. And we recognize, well, 8 and 12 are both even. 5 and 15 look like they have some common factors as well. So let's rewrite this as 5 times 8, or let's do it the way that we did before to keep it consistent. 8 times 5 over 12 times 15. Now let's take a look. 8 and 12 have a common factor of 2. So 8 and 12, when we divide by 2, this becomes 4, and this becomes 6. But wait, 4 and 6 also have a common factor of 2. So you're telling me I can divide 4 and 6 by 2 again? Yes. 4 divided by 2 is 2, and 6 divided by 2 is now 3. Let's do the same with 5 and 15. 5 and 15 have a common factor of 5. Again, common factor means that these numbers are divisible by some same number. In this case, it's 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. Not even this time. Yes, Jimmy. These numbers are no longer even. However, they still have a common factor of 5. Both numbers are divisible by 5. And now we multiply across. 2 times 1 is 2. And 3 times 3 is 9. If you want to add an extra step just to make sure you're not making any mistakes, I do recommend actually rewriting it as 2 times 1 and 3 times 3, just so you know exactly what you did in that previous step. It's never be lazy in mathematics. If you have the time to write it, which you always do, by the way, it took me less than 2 seconds, maybe less than 1.5 seconds to write this part down. Yeah, just write it down whenever you can, especially on exams when you have so many problems and when you go back to check your work. If you skip steps, you're going to have to do that problem all over again. But if you don't skip the steps and you write down step by step your thinking, your logic, when you go back to the problem to check your work, you can point out exactly where you went wrong, or you can see what you did and you don't have to write a single thing again, right? So make sure, again, foundational habits, that's what we're focusing on here in grade 6 through 8 math. Next, 12 over 21 times, before we do that, part A, did anyone get that correct? Who got this one correct? If you didn't, that's okay. We have redemption with part B. Yes, Amy got it correct. Amazing. You were also one of the first ones done. Travis, yes, amazing. All right. For those of you that might have struggled a little bit with part A, let's go through part B together. You didn't simplify. Mabel, amazing. You know, I'm going to say this all the time as well. Whenever you make a mistake and when you fix that mistake, in this case, it's not quite a big mistake because you did get all the way through. But if your teacher asked you to fully simplify and you didn't, that would be a mistake. When you make a mistake and you fix that mistake, that's where the learning is really happening. And that is the beauty of learning. So basically what I'm saying is there's no learning without mistakes. So when you make a mistake, be happy about it because you get to fix it and you get to actually learn, right? Not right, but I got it now. Exactly. Growth mindset. We love it. Let's keep it going. Part B, 12 over 21 times 35 over 16. Let's rewrite this as one fraction. Travis, great point. we have our first improper fraction right here, 35 over 16. How exciting. Let's rewrite it as one fraction under one division bar. So we have, I'm going to rewrite it here just so I don't bump into my previous work. And that's also something that you want to do, right? Rewriting and learning to rewrite it correctly, a very important skill. 12 times 35 all over 21 times 16. Now here we notice something quite interesting. We notice that 12 and 16 have a common factor, but also that 12 and 21, right? 12 and 21 also have a common factor of 3. So we can actually simplify that first before switching the 35 and 12. So let's do that. 12 and 21 have a common factor of 3. Again, common factor means it's divisible by that factor. In this case, this factor is 3. Oops. Wrong button. We have 12 divided by 3 is 4. 21 divided by 3 is 7. Now 4 and 7 have 0 common factors. We have no common factors between 4 and 7. But we do notice that the other numbers might have a say in this. So we're going to switch 35 and 4 and keep the bottom the same. Now I've gotten this question from students a lot. Why do we always switch the numerator and not the denominator? That's just preference. I prefer to stick to one method, but you can feel free to switch the denominator as well, whatever you're feeling that day, right? If you're feeling a little spicy, switch the denominator, see if it works, and I guarantee you it will work. And then now we have 35 and 7. They have a common factor of 7, right? 35 divided by 7 is 5. Really important to know our multiplication tables here. 7 divided by 7 is 1. 4 and 16. Now, we know they're both even, so they have a common factor of 2. But let's get to the next level here. 4 and 16 also are both divisible by 4. 4 divided by 4 is 1, and 16 divided by 4 is 4. Now let's rewrite this as one full fraction again, and we have 5 over 4 as our fully simplified fraction. Amazing. Doesn't matter which way round you simplify. It doesn't matter. It does not matter. But why do we simplify first? Great question, Mabel. Let's do this without simplifying. We have 12 times 35 all over 21 times 16. So now we have 12 times 35. How do we solve that? Well, let's set up a little thing here. 12 times 35, well, that's 0, carry the 1. That's 7, 0, 5, 3, 0, 2, carry the 1, 4. So we have 420 up top. Great. All over 21 times 16. I mean, I can do this again, but I can also do this in my head, so I'll save that work for you. This will be 210 plus 126. So 336 is what it will be. Hopefully I'm correct on that. Someone check me. So we have 420 over 336. We recognize that both of these numbers are even, so we can divide both by 2. And we'll get 210 over 168. Both of these numbers are even. We can divide by 2. 105 over 84. Both of these numbers are even. We can divide by 2. Actually, they're not even. 105 and 84 are not even. And at this point, we can kind of think, okay, well, 105 and 84. Exactly, Amy. Ew, this way is long. Also, 105 and 84. Does anyone know what both of these numbers are divisible by? I, for one, have no clue. So this is where I would stop. But it's not fully simplified. It is divisible by 3. Great. 105 divided by 3 is 35. 84 divided by 3 is 20. What is it? 28. 28. And now 35 and 28. What are they divisible by? They're multiples of 7. So we can divide both by 7, getting 5 and 4. Okay, which way would you prefer? The way we did it first or this second way? So I forget who asked the question, but why do we simplify first? We simplify first to avoid the bigger numbers. Again, with the bigger numbers, I did some mental math here. there is a higher chance that I make a mistake, right? There's a higher chance that I make a mistake, and that's why we simplify first if we can. If we cannot simplify first, then we just multiply through, and we have confidence that whatever number we get at the end is our fully simplified fraction. Okay. Hopefully that made sense. Amazing. Let's keep it going. Now, we talked about multiplying fractions. Let's talk about dividing fractions. Does division work the same as multiplication? Can we just divide across? If you ask your math teacher tomorrow, their instinct will be to say no, because I can almost guarantee that they have never learned it this way as well. I think yes. Let's take a look. Well, 8 over 24 divided by 4/3. If we put this all over one division bar, and we say 8 divided by 4 and 24 divided by 3, this is equal to 2 over 8. And now notice 2 and 8 are simplifiable or have a common factor, therefore simplifiable. 2 divided by 2 is 1, and 8 divided by 2 is 4, giving us 1/4. Now, is this correct? Well, let's think about it. Look at this question at the bottom of the slide. If I asked you to divide a number by 2, what is another way I could have asked that same question? If you're dividing by 2, what's the equivalent operation for dividing by 2? Like we talked about with our chocolates earlier. If we're dividing by 2, we're halving that number, which means we're actually multiplying by cutting in half. Exactly, in half. So we're multiplying by a half. I'm going to write this down. Whenever we divide by 2, that's the same thing as multiplying by 1/2. Now let's look at this 2 and this 1/2. What do they have in common? They have a 2 in common. But do they have a 1 in common as well? Whenever we write a number, that number or variable or whatever it is can always be written over a 1. Because 2 divided by 1 is still 2. Whenever you divide by 1, you get the same thing. You're dividing by 1 whole. So you get the same thing. So that must mean that if we divide by, let's say, 5, what does that mean? That means we're multiplying by? In the chat, tell me. If we're dividing by 5, which is another way to write is to 5 over 1, what are we actually multiplying by? One-fifth. Great, Mabel. 1/5. And this is what we call, great, Travis, this is what we call a reciprocal. We're flipping the number we're dividing by so that we can use a more familiar operation, multiplication. Let's try another one. If we divide by 1/3, then we're actually multiplying by 3 over 1, which is multiplying by 3. And that makes sense. If we're dividing something into thirds, then we're actually multiplying that something by 3. We're tripling it, right? Because every whole we have has 3 pieces. So if we're dividing by that, then we must be tripling the amount that we actually have. So dividing is multiplying, not quite, but I like that question because I know you're thinking, and thinking is always great. Dividing is the inverse of multiplying. So when we divide by a number, we can multiply by its reciprocal. Reciprocal. And a reciprocal is a number multiplied by the original number, making it 1. So for example, the example that we just had, 1/3 times 3 over 1. What does this become? 1 times 3 over 3 times 1, which is 1. 5 over 1 times 1 over 5. That'll become 5 times 1 over 1 times 5. 5 over 5 is 1. So whatever number multiplied by the original makes it 1 is called a reciprocal. So let's try another fraction here. If we divide by 2/3, what are we actually multiplying by? If we divide by 2/3, what fraction are we actually multiplying by, or are we allowed to multiply by? 3/2? Great guess, Amy, because all we're doing is flipping it. Yes, Mabel, 3/2. Let's check it out. Are these two numbers reciprocals? We are correct if these two numbers multiplied together gives us 1. 2/3 times 3/2. That's equal to 2 times 3 over 3 times 2, giving us 6 over 6, which is equal to 1. Boom. There's our reciprocal. Upside down. Basically, yes, flip it, right? Flip it. Let's try that with our very first example. 8 over 24 divided by 4/3. So if we're dividing by 4/3, this will be the same as multiplying by, flip the other fraction, 3 over 4. And let's rewrite this as 8 times 3 over 24 times 4. Well, in this case, 8 and 24 already have a common factor. 8 itself. 8 divided by 8 is 1. 24 divided by 8 is 3. So now we have 1 times 3 is 3, and 3 times 4 is 12. But we can simplify once more. 3 and 12 have a common factor of 3, and 12 divided by 3 is 4, leaving us with 1/4. Now, what I did here, I didn't completely simplify under the 1 division bar, and I simplified another time here. And that's okay, as long as you get to the fully simplified version at the end. Let's try the second example. 5/6 divided by 3/10. We can rewrite this as 5/6 times, flip the 3/10, and that becomes, 10/3. 10/3. And we can rewrite this all over 1 division bar. And we recognize, well, 5 and 6, no common factors. 10 and 3, no common factors. So let's switch them up, because we know 10 and 6 have a common factor of 2, because they are both even numbers. 10 divided by 2 is 5. 6 divided by 2 is 3. So now we have 5 times 5 and 3 times 3. And that would be our final answer. 25 over 9. And now we know how to multiply and divide fractions. We know how to play with fractions now. Let's see what our next slide holds. Practice. Let's simplify these following fractions. I want you to try just one of these problems, A, B, or C, within the minute that I give you right now. Within a minute, try to solve one of these. If you get through one of them, try another one, right? I'll give you 1 minute starting now. Try it out. Ooh, great question, Mabel. Can we flip the other fraction instead? That is a great question. Let's think about it this way on the side. If we have 4 divided by 2, that's the same as having 4. So we get half of 4, which is 2. Now let's think about that. We're taking 4 and we're dividing by 2. But if we, that's a minute. If we flip the 4 instead and we get 1/4 and then say, okay, that's going to be multiplied by the 2, that wouldn't make any sense, right? Because we just took the 4, which is the whole thing that we're dividing, and we flipped the original, right? Something's off. We're not working from left to right anymore. Now we're working right to left. But whenever we read in English or whenever we do math, we always work from left to right. That's why we do not flip the first number. Exactly. Now this would be 2 divided by 4. Exactly. I don't know if I've completely convinced you yet, Mabel. But Amy's statement helped, right? If we flip the 4, then now we're doing 2 divided by 4 instead of 4 divided by 2. Oh, you get it? Okay, great. Amazing. All right, that was about a minute. Let's take a look. If you solved letter A, let me know what you got in the chat. Of course, Mabel. Great work. I guess no one did level A, part A. I guess you all tried the tougher ones, B and C. That's amazing. Let's try letter A, just as a warm-up then. 4/5 divided by 2/7. Let's take a look. We can rewrite this as 4/5 times 7/2. And this will be 4 times 7 over 5 times 2. You did C. Amazing. Looking forward to your answer, Travis. 4 times 7, 5 times 2. Well, 4 and 5, no common factors. 7 and 2, no common factors. And now that we're getting a little comfortable with this, you do not have to keep flipping them around. As long as the numbers are parted by the division bar, you can just cancel. 4 and 2 have a common factor of 2. So 4 divided by 2 is 2, and 2 divided by 2 is 1. 7 and 5 are prime, meaning that they have the only factors they have are 1 and themselves. So we can multiply this through. 2 times 7 is 14, and 5 times 1 is 5. Anyone try letter B and got an answer? Share it with us in the chat as I start this problem. We have mixed numbers now. Now it's really difficult to solve division with fractions with mixed numbers. So what we're actually going to do here is rewrite them, convert them into improper fractions. So we have 2 and a third, which can be rewritten as 2 full 3s. So that's 2 times 3 plus a 1 over 3. Divided by, this is 1 full 5 plus that remaining 2. So 1 times 5 plus the 2 all over 5. Let's rewrite this. 2 times 3 is 6 plus 1 is 7. And we're going to divide this by 5 times 1, which is 5, plus 2 is 7, all over 5. Equals. Now, dividing by a number, we can multiply by its reciprocal, or its flipped version. So 7 over 3 times 5 over 7. And we recognize this as 7 times 5 over 3 times 7. 7 is a common factor of itself, actually. They're the same number here, so they cancel. And we're left with 5 over 3 as our final answer. Okay, now I'm guessing a lot of you did C. Let me know what you got for C while I start this problem off. We have 3 full 4s. So we're going to have 3 times 4 plus that extra 1 on top, all over 4, divided by a 2. Well, dividing by 2 will be the same as multiplying by 1/2. I jumped the gun here. Let's simplify this initial fraction as well. 13 over 8, 13 over 8. Amazing, Travis and Amy. 12 plus 1 is 13 over 4. And now we multiply straight across. Now, these are smaller numbers, so no need to write it under one division bar here. 1 and 2 are literally the smallest numbers we can work with when we're multiplying. So we'll multiply across 13 over 8, and that is correct. Remember, learning is never a competition. If we're all getting there together, that's the beauty of it. But I love the competitive spirit as well. Great, great stuff. Amazing, everybody. Here is the end of today's lesson, our application. We always want to end with how can we apply what we just learned into an actual real world, real life situation. That's the beauty of math, right? Lucas spends 1 2/3 minutes reading each page of his favorite book. How many pages can he read in 30 minutes? Now we're thinking, okay, Eddie just taught us about multiplying and dividing fractions. I wonder if we're going to be using either one of them. Well, let's think about this question again. If Lucas spends 1 2/3 minutes per page, how many pages can he read in 30 minutes? Well, we can start off by saying, okay, well, let's just add up 1 2/3 until we get to 30. And that'll be how many pages he read. But there must be an easier way to do this. This method is going to take us a lifetime. Maybe not a lifetime, but a lot longer than we'd want. 1 2/3 plus 1 2/3 plus a lot of these equal a 30. So the question here is, how many times will 1 2/3 go into 30? How many times will 1 2/3 go into 30? So what's the operation we can use here? We can say, maybe, divide 30 into as many 1 2/3 as possible. Then we'll know how many times 1 2/3 gives us 30. This is an x, by the way, an x. 1 2/3 times the number of pages will equal 30 minutes. Or in other words, 30 divided by 1 2/3 will give us the number of pages. And let's work this out. 30 will then be divided by 1 full 3 will be 3 plus 2 over 5. So we have 5/3. This is 30 times 3/5. And we can rewrite this as 30 times 3 over 1 times 5. Because reminder, whenever we have a number, we can always write it over 1. 30 and 5 have a common factor of 5, giving us a 6 on top, 1 on the bottom. 6 times 3 is 18. The bottom we have 1. But whenever we divide by 1, we're just going to get what was in the numerator. So we have 18. Don't forget our units of measure. 18, what does that number represent in this problem? It is the number of pages. Final answer. So Lucas can read 18 pages in 30 minutes, and that's why it takes him about 1 minute and 2/3 of a minute to read each page of his favorite book. Math is greater than reading? Actually, it makes more sense. Actually, that makes sense because math involves reading. Reading is in math. So, okay, yeah, I like that. That's great. Do you need to say 18 pages for full marks? Great question. Whenever you are given units in the problem, yes, you have to include units in the answer. Whatever is given in the problem, you must give in your answer. W. Lucas, yes. All right. Well, that was our lesson. But if you're still here and you enjoyed the lesson, put a plus in the chat. If you enjoyed the lesson and you're still here, put a plus in the chat for me. That would be awesome. And while you do that, go and call your parents or guardians because I want to share something really special with everyone. So grab your adult, whoever's there with you, call him over to the screen. I have something really special to share. Great, I see Amy's still here. Mookie still at number 1. Mabel's still here with 2 pluses. Love the energy. Jimmy's still here. Jessica, I see you. Amazing. Thanks for the lesson. That was surprisingly fun. Amazing. Thank you for the encouragement, Jessica. That's what we're here for. Yeah, an hour goes by quick when we're having fun, right? All right. So our lesson may be ending, but your progress doesn't have to. MyEdSpace, grade 6 through 8 math, the full course will start on October 6th. And this is what you'll be getting. This course will include 2 engaging live and interactive lessons each week, just like the one you had right now. It'll start on October 6th, every Monday and Wednesday, 5 to 6 p.m. Pacific time. You'll get video recordings to revisit each lesson. Believe it or not, this lesson right now, where we're at, is also being recorded and will be uploaded so that you can rewatch, or students and parent guardians that missed this stream could rewatch it at a later time. Professionally designed workbooks. Now today, I should have mentioned this at the beginning, but you should have gotten an email where you can download the workbook that had every single slide on there, and you can annotate the workbook as you move along so you don't have to rewrite the question and things like that. Practice with exam style questions. So not only do you get these interactive lessons and the workbook to follow along with these lessons, and you can revisit these lessons, which you can't do in a tutoring session, you also get practice. You get homework that you can solve. And now for the solutions, you will get to watch detailed video solutions made by me. Yes, these are all with me, by the way. This is all with me. You'll get video solutions to your homework so that after you finish your practice, we call it homework, but we'll call it practice. It's more familiarly known as homework, but we'll call it practice because that's better, because practice makes perfect. For your practice problems, you'll be given detailed video solutions also made by me. You'll see it like you see me here, and I'll be solving the problems and giving you little nuggets here and there of wisdom as well. But how much is it? For context, when I used to be a private tutor, let's get some guesses in the chat. How much do you think I used to charge per hour to any of my students, my previous tutees? You've printed your workbook. Amazing. 75. That's a pretty good guess. Mabel asked, how many do I get? As in lessons? Number of lessons? Mabel said 150. Wow. Amy says 120. Wow. Okay. These are some great guesses. Jimmy says 50. Great. Very affordable, or more affordable. 80, right in the middle, Mookie. I see you. Previous tutor was $80 each lesson. Wow. Okay, well, but you're better. Wow, thank you. Well, I used to charge a minimum of $100 per hour and anywhere up to $200 as well. I've helped students for their entrance exams for an MBA program, which is a master's program after college, things like that. I do charge a little more because the math is way more complex, but my minimum base charge was $100 per hour. Now, the thing with private tutoring is that families have to choose between what works and what they can afford. So effectiveness or affordability. It's really hard to find both, almost impossible. And that's why we created this, My EdSpace. All this, engaging live interactive lessons twice a week, 60 lessons total, video recordings to revisit lessons, professionally designed workbooks, practice with video solutions, all that for $99 a month, which is 8 times cheaper than my hourly rate. $99 a month. And to protect you from any risks, we provide a risk-free 30-day full refund guarantee. Very important. We like insurance. But it is first come, first serve. So this is a limited time offer. The $99 a month is a limited time offer. So if you're interested, text me, code word START. So text me START to this number, or you can scan this QR code and we can start our discussions. Let's see. Yes, so scan this QR code to keep going with this, to start your journey at My EdSpace, to start your journey in having fun with math, to loving math with me, directly with me. And we have some time for a Q&A, but I'll leave this QR code up as well. We have some time for a Q&A, so if you have any questions, please feel free to ask in the chat. Otherwise, thank you for your time today, and I hope to speak with you or chat with you through text, SMS, or I'll see you on October 6th when the course starts. Tell your mom, yes. Save this number, save the code word, it's START. You want to text START to this number, and you'll be able to speak with me more about how to purchase the course. Thank you everyone for joining. If you have any questions, feel free to ask as well. The lessons will be Mondays and Wednesdays starting on October 6th from 5 to 6 p.m. Pacific time. And it will go through the entire school year. We take breaks on holidays like Thanksgiving, Christmas, things like that. It starts on October 6th. Monday, October 6th. So we have some time, but again, this is a limited offer and it's first come, first serve. We don't have the capacity to get everyone that wants to join the course. So if you want this offer, $99 a month, go ahead, text the code word START to this number, or just simply scan the QR code and it'll prompt you to text START to this number. Yes, so this is basically pre-algebra in schools. but I call it grade 6 through 8 math because I do really cover everything that you need to know from grade 6 all the way through grade 8, right before you get into Algebra 1. So after my course, you will be ready for Algebra 1. And I know these math courses, they're called these subjects and they're not tied to a certain grade level. And that's why I call it grade 6 through 8 math. But be on the lookout. We might change it to pre-algebra. We might change it to middle school math, but they all really mean the same thing. And so yes, it is the same class as in school. Good questions, Jimmy. All right. If there aren't any more questions, thank you everyone for your time. Hope to see you via text or on October 6th.